Hello everyone, welcome back to NEETAtomix. So yesterday we have learned about the law of mass action. The topics to be covered today are Gibbs free energy, standard Gibbs free energy, standard Gibbs free energy change, relation with equilibrium constant, relation with equilibrium coefficient. We are going to start the first topic, that is Gibbs free energy. Gibbs free energy. So the equation is given by delta G is equal to delta H minus T delta S, where delta G is the Gibbs free energy, delta T is the temperature which is in Kelvin, delta H is the enthalpy change, delta S is the entropy, T temperature in Kelvin. If the delta G is negative, there are three cases. The first case is delta G is negative, delta G positive, delta G is equal to 0. If the delta G is negative, the reaction is spontaneous. Delta G is positive means the reaction is non-spontaneous. Delta G is 0 means the reaction is in equilibrium state. If the delta G is negative, the reaction is proceeding in the forward direction. This is in the backward direction. Delta G positive, backward, and delta Z 0 means rate of forward is equal to rate of backward, as we already have learnt in the previous class. Next is standard Gibbs free energy. Standard Gibbs free energy change. So what is the difference between Gibbs free energy change and the standard Gibbs free energy change? This standard Gibbs free energy change is under the standard temperature and standard pressure. What is the standard temperature? Under standard conditions, what is the standard temperature? 298 Kelvin, and standard pressure. Temperature is 298 Kelvin. Pressure is equal to 1 atmosphere, right? So delta G naught, Gibbs free energy, standard Gibbs free energy is represented by G naught. So delta G naught is equal to delta H naught minus delta T delta S naught. This is the standard Gibbs free energy change, is given by this equation. This is naught. Now there is another relation for delta G naught. One minute. Sorry for the inconvenience caused. So there is another relation for delta G naught, which is the standard Gibbs free energy change for the reaction, that is equal to delta G formation of products minus delta naught G formation of reactants. So this is the relation for standard Gibbs free energy. And in the similar way, for delta H of the reaction is equal to delta H formation of the products minus delta H formation of the reactant. We will illustrate by an example. Let us take an example of I2, which is a solid, plus H2S, which is a gas, gives rise to 2Hi, which is a gas, and sulfur, which is a solid. Now for this question, they gave delta G naught, which is the standard Gibbs free energy change of Hi, 1.8 kilojoule per mole. And they also gave delta G naught for H2S, gas, Hi, solid. H2S gas is 30 kilojoule per mole. So we have to find the delta G naught of the reaction. I already said you that delta G naught is equal to delta G naught formation of the products minus delta G naught formation of the reactants. This is the formula we have to use. So if we substitute the values, 2 moles of Hi are there. So for 1 mole, the delta G naught is given as 1.8. 2 into 1.8 minus 30. 1.8 minus 30. So we'll get delta G naught as negative, which means the reaction is spontaneous reaction. Delta G negative means it is a spontaneous reaction. Now there is an important point. Note. Delta G naught formation of elements. The elements which are in the standard state, the commonly observed state, their standard Gibbs free energy is 0. For suppose standard state. commonly observed state. Standard state means commonly observed state. For example, O2 is a gas, right? Commonly observed state. Observed. Observed state is 0. For example, delta G formation is equal to O2 is equal to 0, which is a gas. H2, N2, Cl2 is equal to 0, and Br2 cannot exist in gaseous state. So Br2 of gaseous state, the commonly observed state of bromine is liquid state, so it becomes 0. In the same way, iodine, it cannot be expressed in gaseous state. The commonly observed state is solid, so solid is equal to 0. We will study with an example. Let us take methane. CH4 plus 2O2 gives rise to CO2 plus 2H2O. They gave delta H formation, delta H enthalpy values for CH4, CO2, H2. They also gave delta S naught values. So for methane they gave minus 75, 180, nothing, because it is a gas. This is also a gas. This is a gas. This one is a liquid. They didn't give anything for oxygen, so, and this they gave us 200. This one is minus 400, 220, minus 370. At temperature T is equal to 298 Kelvin. So if we find the delta H of the reaction, it will be delta H minus of the products minus delta H of the reactants. So this one is given in kilojoule, so multiply it with 1000 and get the answer. This one is a try yourself question, homework. You can substitute all these values in the equation and get the answer. Now we will study relation with equilibrium constant. Let us consider a reaction of type A plus 2B gives rise to 3C plus D. Q, here it's Q. This one is reaction quotient. What is this reaction quotient, and is there any difference between equilibrium constant and reaction quotient? Yes, There is obviously a difference between equilibrium constant and reaction quotient. What is reaction quotient? The ratio of concentration of the products to the reactants at any instant of time is called reaction quotient. But equilibrium constant is when the rate of forward reaction is equal to rate of backward reaction. The ratio of concentration of the products to the reactants when the ratio of forward reaction and backward reaction. When the rate of forward reaction is equal to rate of backward reaction, the concentration of the reactants to the products. But reaction quotient is at any instant of time, at any time. So this one is represented by C to the power 3, D to the power 1 by A to the power 1, B to the power 2. Can be defined at any stage of the reaction. Can be defined at any stage of the reaction, at any stage, at any stage. For the same equation, if you write equilibrium KEQ is equal to molar concentration of C cube D power 1 A power 1 B power 2. This is the equilibrium constant. Equilibrium concentration. This is the equilibrium concentration. Now the delta G is given by delta G naught minus delta G naught plus RT log Q to the base E. This is the one of the most important relation that you frequently use in the problems. So this is the relation between Gibbs free energy and Q, which is the reaction quotient. Now let us consider an important case. At equilibrium, the reaction quotient is equal to equilibrium concentration KEQ. Q equal to KEQ. Now delta G is equal to 0. Here many students get confused. Delta G, which is the Gibbs free energy, and not standard Gibbs free energy, is not equal to 0, which is delta G naught is not equal to 0 at equilibrium, but Gibbs free energy is equal to 0. So if you substitute these values in the equation which we got in the previous slide, we'll get 0 is equal to delta G naught plus RT log KEQ to the base E. If you bring delta G naught to your left hand side, delta G naught is equal to minus RT log KEQ to the base E. This one is also an important relation. And now if you substitute log 10 in the place of E, delta G naught, you have to multiply the whole equation with minus 2.303, right? You remember in thermodynamics also, minus 2.303 RT log 10 KEQ. This is another most important relation. Most. Now let us discuss a PYQ. These are the relations. PYQ of JE 2017. Let us take another 2007. JE 2007. Let us consider an equation. A gives you B, reversal B. Delta H R is equal to minus 54.07 kilojoule per mole. And they gave R value as 8.314 joule per mole Kelvin. And they also gave you delta S naught of the reaction as 10 joule per mole. They ask you to find log KEQ to the base 10. Now, according to the previous relation I said, this is an important JE question. What is the relation? What was the relation we got? Delta G is equal to 2.303. Delta G naught is equal to minus 2.303 RT log KEQ to the base 10. This was the equation we got, right? This was the equation. So delta G naught, if we substitute the values, they gave 2.303 into 8.314 into 298, which is the temperature value, as 5705. This is the standard value. So delta G naught is equal to delta H naught minus T delta S naught of the reaction. Now delta H naught was given as minus 54.07 kilojoule per mole minus 298 into 10 joules. This one is in the kilojoule and this one is in the joule. Multiply with 1000. This with 1000. So you get minus 54070 minus 2980. The answer you will get is 57050. And now you substitute this value in the equation. We got delta G naught as 57050 is equal to, they gave you this value 5705 into log KEQ. We have to find log KEQ to the base 10. This one is 10 times, and you get log KEQ to the base 10 value as 10, and the answer is option B, which is 10. And now another question, which is JEE 2015 question, 2015 PYQ of JEE. And the question says that 2NO plus O2 gives rise to 2NO2, which is a gas. This one is a gas. This one is a gas. And now delta G naught is equal to of NO is given, that is 86.6 kilojoule per mole at 298 Kelvin. This is the temperature, and this one is the delta G naught value. So sorry. Yeah. Now the question is, you have to find delta G naught of NO2. Let's solve here. Yeah. They gave you the value of K as 1.6 into 10 raised to the power 12. And they gave you the options. Okay. We can solve this by delta G naught is equal to minus RT log KEQ to the base E, because they gave options to the base E. So no need to multiply the equation with minus 2.303. Then delta G naught is equal to minus R, and the temperature is given as 298 Kelvin, log to the base E 1.6 into 10 power 12 to delta G naught is equal to minus R 298 log to the base E 1.6 into 10 raised to the power 12. So if we bring the 2 which is in the left hand side to the right hand side, then it will become minus 1 by 2 into 2 into, it was given as 86.6 minus R 298 log 1.6 into 10 power 12 to the base E. This is your answer. It will be given as 0.5 into 8660, because this one is in the kilojoules. Kilojoule, you have to convert into joule, so you multiply with 1000. Yeah, that's it for today's class. Today's class is a little short. If you like the video, please like the video, share the video and subscribe to this channel NEETAtomix. Thank you. Bye.